Dear students, welcome to the class of business mathematics again, and today I am going to discuss a very important topic, which is piecewise linear functions, and this is part 1 of this lecture. So first of all, we need to understand what is a piecewise linear function. So I am going to discuss here two mathematical example in order to understand piecewise linear function first. Then we will enter to the application of this topic, and let us draw this function first. This is a piecewise linear function. You see there are three p's. First piece from -5 to 0, and second piece, this function is a line. This is a linear function. So this is a linear line, and which is defined from 0 to 5, and this is another line which is defined from 5 to 10. So this is a piecewise linear function. We cannot say fx is a linear function, but we should say fx is a piecewise linear function. And there are how many pieces? There are three pieces or three parts of this function. All of them are linear line. So the first piece start, you see the first piece start at -5 and end at 0. Let us put -5 here. If x equal -5, then fx will be 8. Therefore the point the initial point of first line will be -5 and 8, and it will end at 0. When x equal to 0, fx will be 3. So this is the end point of the first line, and we need to fill this circle because 0 is included with this interval. And the second line start at 0, but 0 is not included with this interval. So if we put 0, then the second line will start from 0, 3. You see, from 0, 3. But for the second line, it should be an open circle. So since the end point of the first line and initial point of the second line is the same point, so let us denote this point by a filled circle. So the second line will end at 5. When x equal to 5, fx will be 10 plus 3, which is 13. So 5, 13 is the end point of second line, and the third line will start again from the same point. So we can fill it by a little circle, and when x equal to, you see, when you put x equal to -5, then it will be 13. So the initial point of the third line is 5, 13, and it will end at, so when x equal to 10, then it will be -10 plus 18, which is 10, 8 point, and we need to fill it because the third line will end at here. This is the high end of the third line. So you see, this function is a piecewise linear function, and there are how many pieces? The first piece, which is a linear function, second piece linear function, and third piece, which is also a linear line. So we can say this function is a piecewise linear function. And let me discuss another example. From this graph, let us write the function conversely. How can we write piecewise linear function from this graph? So here the first piece start at 0 and end at 6. The first line start at 0 and end at 6. So y equal or mx, and this is the upward sloping line. So the slope is positive. The coefficient of x is the slope, we know, mx, plus c is the y-intercept, which is 2, 1, 2. So the first piece, this function, will be within this range, within this interval from 0 to 6, and you need to fill this circle. since 0 is included with this interval, and also we need to fill this circle. And the second line has slope 1.25, so it will be 1.25x. And now what will be the y-intercept for the second piece? So you see, if we extend back this line, then it will touch the y-axis at this point, and at this point, let's say the value of y is 1, 2, 3. So let's say the value of y is 1, 2, 3 at this point. 1, 2 or 2.5 minus 2.5. So the y-intercept will be negative 2.5. And this piece is valid for 6 to 10. The initial point of second line is 6 and it will end at 10. So, but 6 is not included with this interval. So 6 to 10 is the second interval. Now the third line start at 10 and end at 15. So the range, let me write first the range. It will start at 10 and end at 15. So if we extend back this line, then it will cut at y-axis, let's say at this point, and the value of y, it will approximate to what? So the value of y will be 1, 2, 3, 4, 5, 6, 6, 7, 8, negative 8. So, and the slope of this line is 2, so the equation will be 2x negative 8. So this is the piecewise linear function corresponding to this graph. So now let's try to understand some business application related to a piecewise linear function. And in our real life, when we are calculating gas bill, electricity bill, or tax function that is related to the piecewise linear functions. And in this lecture, I am going to discuss two problems in part 1, which will be related to the gas bill, and other two problems in the part 2 will be related to the electricity bill, and other two problems I will discuss in part 3, which will be related to tax function. So let me read this problem first. Boston Gas Company charges its customers according to their use of gas as follows. A $6.71 is the customer charge. So this customer charge, in our country we say meter charge. So this is fixed. Even if you don't use any gas, you need to pay this amount each month. So this is the customer charge or meter charge, and $0.7376 per therm, and therm is the unit of gas. So for the first 160 therms. Therefore your first piece or first range will be from 0 to 160 if x indicates the number of therms, and the second piece will be over 160 therms, and the per unit therm will be $0.68. So what you need to do here is that you need to determine the cost function and draw its graph, and we need to also calculate the charge for using 120 therms, and we need to also calculate the charge for using 200 therms. And conversely, if you are given the charge, total charge, how many therms were used if the total charge is this? So this is the question. Now the first function, we need to determine the cost function. So the first piece of the cost function will be, let us denote by y1, and let's say x is the number of therms or number of units, is the number of therms or number of units. So the slope of the first line will be this. This is because in the cost function y equal to mx plus c, we know m is the variable cost per unit and c is the fixed cost. So here for the first piece, 0.7376 is the variable cost per unit charge. So 0.7376 x plus fixed cost, which is 6.71, and this piece will valid when x is from 0 to 160. And now let us think about second piece. Let us denote by y2, and this piece will be over 160. So here x greater than 160. So here note that if you are using over 160 therms, but for the first 160 therms your payment will be same. So for the first 60 therms the amount will come here, and for the remaining part means 68 into, let's say if you are using 200 therms, then the remaining part will be 200 minus 160. If you are using 300 therms, then the remaining part will be 300 minus 160. So since we are looking for a function, cost function, instead of 200 or 300, we need to put x, variable x, since x indicates the number of units. So x minus 160 times 0.68, and for the first 160 therms the payment will be same, and if you put here 160, then it will be 0.7376 into 160 plus 6.71. This will be equal to 124.726. 124.726. So 124.726 plus this is the second function. And you may think that where is the fixed cost for the second piece? If you put 160 here, then fixed cost 6.71 is already included within this amount. Your customer charge is included here. So if you look in this solution manual, you will understand more clearly. X represents the number of terms and y represents the cost function. So the first part of the cost function for the use of 160 therms will be this one, and the cost of first 160 therms we have calculated already, 124.726. So the second part of the cost function for use of more than 160 therms is given by this, and this is your second function. You may think that where this 15.926 comes from. If you simplify here, then 0.68x minus 0.68 into 160 plus 124, and that will give us 15.926. So now equation 1 and 2, if we put together, then we will get our required cost function, which is this. And let us draw the graph later. Before that, what is the total charge for using 120 therms? And 120 therms is within your first range, within your first piece. So you need to put 120 in this, in the first part, y equal 0.7376 into 120 plus 6.71. That will be the answer of your B. And C, you need to calculate the total cost for the using of 200 therms. So 200 is within second range, therefore we need to put y equal 0.68 into 200 plus 15.926. So that will be $151.926. for the using of 200 terms. Now you are given y in this part. In D you are given y, and this is your y total charge. You need to calculate x, how many terms were used in total charge is this. Now the question is which function you need to use in order to calculate x. Here your total charge is this. Which function you will use in this case in order to calculate x? If you look at here, the customer type 1 will pay maximum this amount. If you are within this range, if you are using 0 to 160 terms, then your maximum charge will be 124.726. And here the given charge crosses this amount. So you need to use the second function in order to calculate x. So that is here, you see we use second function. 355.93 equal 15.926 plus 0.68x. That will give us 500 terms. Now let us sketch the graph of the cost function. You see the first line start from 0 and end at 160, and we already have this result in our hand. From the first equation, when x equals 0, then y will be 6.71. The first line initiates from this point and end at 160. And from our previous result in this part, we know when x equal 160, then y equal 124.726, and when x equal 200, then y equal 151.926. So these results we can use here. Let's say 160 is here and 124.926 is here at this point. So when x equal 160, then y equal 124.926. It means the first line will end at this point. So let us just imagine that 124.926 will be here. So now we can sketch the first line. This is the first line, and second line will start where the first line end, because if you put 160 in the second line, the result will be the same. You see 0.68. Let us put 160 in the second line. So 0.68 into 160 plus 15.926, and that will be equal to 124.726. So the point where first line end, the second line will start from that point, and the coordinate of this point is 160, 124.726. The coordinate of this point is 06.71, and the second line will end at infinity. It goes to infinity. So for example, we can consider another point in order to sketch the second line, because second line will start from here. So we need another point to sketch it. So let us use this point 200, 151.926. So if 160 is here, then 200 will be here, and 151.926 will be in this place. Now the question is why I consider I understand that this point is 151.926. 151.926. So in that case you need to look here, because the slope is smaller in the second line. The second line will be less steep than the first line. If you continue first line, then it will passes through this way. Therefore, the second line will passes through a uh, bit less steep. So considering the slope of the second line, I can easily understand that the second line will be less steep than the first line. And you need to put an arrow sign here because it will continue up to infinity. So this is the graph of your cost line. Now let us solve problem 2. Colonial Gas Company charges its customers according to their use of gas as follows. $6 is the customer charge, so this is the fixed cost, and this is the variable cost per unit. So here per unit B means 100 cubic feet, and for the first 20 units, therefore your range, the first range will be from 0 to 20, and the first function will be y equal 1.18x plus customer charge 6. So for the second piece, the per unit cost is this, which is over 20. Therefore, the range for the second piece will be x greater than 20. So 0.806 per unit for each unit over 20. And for the first 20 units, the payment will be 29.6. If you put 20 here, 1.18 into 20 plus 6, it will be 29.6. Plus per unit charge 0.806 into over 20 x minus 20. So if you simplify the second line, then the cost function, required cost function will be this one, y equal 1.18x plus 6, which is from 0 to 20, and y equal 0.806x plus 13.48, which is the cost function for x greater than 20. Now from this cost function you can calculate the total charge for total and average charge for using 15 units. So the total charge for using 15 units you will calculate from here. You must need to calculate from here. And the average charge, which is total charge divided by number of units. This is the total charge. So if you divide total charge by the number of units, you will get average charge. And the total charge for 50 units, you will get from the second one, 0.806 into 50 plus 13.48, which is $53.78, and the average charge will be this. And the last part, how many units are used if total charge is this. And you see the total charge is greater than this amount, is greater than 29.6. Therefore is greater than 29.6. Therefore you must need to put this charge 73.93 in the second function. In the second function, y equal 0.806x plus 13.48. So that will give us 75 units. So now let us sketch the cost function. The first line will initiates from 0 and end at 20. So when x equal to 0, y equal 6. So let's say 0.6 is this point, 0.6. And when x equal to 20, y equal what? Y equal 29.6. So now we can put 20 and 29.6. Let's say 20 is here and 29.6 is this point. (20, 29.6). So let us draw the first line. And the second line we will initiate from this point. So in order to draw second line, we need another point, which is 50, 53.78. 50, 53.78. And you see the second line is less steep. The slope is smaller than the first line, so it will be less steep, and the other point will be 50, 53.78. Let's say 50 is here and 53.78 is here, so 50 comma 53.78. Now we can sketch two lines. The first line is this one, and second line will initiates from the point where the first line ends, and it passes through this point. And since the slope is smaller than the first line, so I need to put an arrow sign here. So this is the graph of this cost function. We understand that the first line initiates from 0 and ends at 20, and when x equal to 0, y equal 6, and when x equal to 20, y equal 29.6. So this is the end point of the first line, and second line is less steep than the first line, since the slope is smaller than the first line. And in order to draw second line, we need another point, and we have the result here: when x equal to 50, y equal 53.78. So this is the point 50 comma 53.78. And why I consider this point here? Because the second line I said less steep than the first line. So this is the graph of the cost function. So that's the end of this lecture, and in my second part of this lecture I will discuss the same topic, piecewise linear function, but I will consider two examples related to the electricity bill. Thank you very much.